take these. Oh, wait, hold up, people, Dan. If everything's made of atoms and atoms are mostly empty space, that means I'm mostly empty space.
Well, yeah, I guess that's true.
Well, what about poor Marina here and our audience?
Well, yeah, atoms are mostly empty space, so I guess everything is pretty much empty space. But you know what? Let's give our nucleus a break. Can we have a round of applause for Marina?
Marina!
She was fantastic.
Thanks, Marina. Shake my hand. You were the best nucleus a bunch of whirling electrons could ever have. Now split.
Joel, don't ever tell a nucleus to split. What are you trying to do, kill us all? All right, I tell you what. Let's you and I each be our own atom models. Here, you need to put that on.
I get to be a model?
Yep, that's going to be your nucleus on your chest there.
All right.
And your hands are going to operate the electrons.
I get to be a model.
That's right.
Does this shirt make me look fat? Is this okay? No, good, thanks.
Joel, what?
Just a minute.
Why are you wearing a tie? What's the tie for?
Well, if I'm going to be a model, I want to look good.
Oh, boy. Okay, well, here's your electrons. Here you go. Hup.
Oh. Ooh, yeah. Ta-da. Woo! Nice. Dan, we have a technical problem here.
What's the technical problem?
The electrons are too close to the nucleus.
Oh, well, we're not doing this to scale, Joel. Your arms aren't long enough to reach out to Lexington or Concord. This is to show you something else about atoms.
Now what?
Well, you see, atoms are always in random, ceaseless motion. And the more heat there is, well, the more they move around. See, we're beginning to warm up, so we're beginning to jiggle around.
I see. So we're juggling atoms.
That's right. And the hotter we get, the more we move.
Wicked cool!
No, Joel. Wicked warm.
Woo! I like to move it, move it. He like to move it, move it. You like to move it, move it. We like to move it! Yeah!
Yes, and Joel, sometimes two atoms get attracted to one another.
Wait, Dan, I want to be my own atom, okay? You're not my type.
Science, Joel. Joel, no.
Help me.
Like brothers, Joel. They get attracted like brothers. Yeah. And when two atoms get attracted to one another, they bond by sharing.
Okay. Sharing?
Yeah.
Oh, I'm good at sharing. Last night when I was going to the bathroom.
No, Joel, no.
You should.
No,
What?
That would be oversharing. You see, when atoms get attracted to one another, they bond by sharing electrons, like this. Hup.
Whoa, so it's one big jiggling, juggling, electron sharing party at the nanoscale.
Thank you.
Woo! Yeah. Nice.
Hup. Yes, things are really moving fast down there.
I'll say.
And you know what? If we're going to a jiggling, juggling, electron sharing party, I think I should be the one to wear the tie.
No, wait.
Don't you?
I'm the model. I wear the tie.
I'm more the brains here.
I wear the
So
tie.
I think I should have the tie. It's
No,
got character,
Dan.
really.
I wear the tie.
It doesn't matter who wears the tie, okay?
I look better.
Now give it back. Now, as I was saying, things are really moving around down there in the nanoscale, even inside solid objects where lots of atoms are bonded together, like this stage.
Like this stage here?
You got it.
You're saying this solid stage is actually made of bonded jiggling atoms.
That's right, and if you'll remember, atoms are mostly empty space.
What? Wait, there you go again. Hold on.
What?
Dan, you just said this solid stage is mostly empty space.
Well, yeah, matter, stuff is mostly empty space.
Matter is mostly empty space, Dan. That's like saying this is mostly nothing. Well, it feels pretty solid to me.
Well, to us, it does feel solid, but you see, inside each one of those atoms, it's mostly empty space. Well, it's kind of filled with all the waves of those electrons.
I can't take any more of this weirdness, Dan.
That's the weird and wavy world of quantum physics. But hey, let's leave the insides of atoms aside and move on up to the nanoscale, where we're dealing with bunches of atoms and molecules.
What a relief.
Well, I gotta tell you, Joel, it's pretty weird at the nanoscale, too. And stuff just behaves differently than what we're used to at the human scale.
Now what?
Well, it would be very difficult to juggle at the nanoscale.
I was afraid that's where you're going with this. Why?
Well, for one thing, gravity really doesn't amount to much compared to other forces. It's pretty weak.
I thought that was only up in space, like in the space shuttle.
Well, yes, but in inner space, too. You see, atoms and molecules are so small that they have hardly any mass or weight. They may as well just jiggle off in this direction as in that.
Oh no, Dan, that's terrible. Gravity is a juggler's best friend. How do those poor little guys juggle with so little gravity?
Yeah, and Joel, there's something even worse.
What could be worse for a juggler than no gravity?
Oh, you're not going to like this. Here, put this on. You see, Joel, it's incredibly sticky down there at the nanoscale.
Sticky?
Yeah, sticky.
I don't like the sound of that.
Well, things tend to stick to one another.
You mean like a booger sticks to my finger?
Kind of like that, but more like the way a gecko sticks to a wall.
Oh, can I get it off? It escaped.
Well, that's actually kind of fun, isn't it?
Help me.
Ooh, hey. Hey, does anyone else want to try? Oh, yeah? Here you go.
Wait a minute.
You can throw that right at Joel.
Wait.
Here you
Oh.
are. Some back
Hey,
here. There you go. You
careful.
look like you have a pretty good arm. Let's get over this way
can't
here,
believe
too.
this.
Here, you want to throw that on Joel? Help
Right
him see
here.
how sticky it is at the nanoscale.
Man, look out.
There you go.
I
Throw
guess
that
I'm
right
really...
on him. Thanks. Perfect.
I got it.
Wonderful. Oops, sorry. Can you get that?
I guess I'm
Here
really
you go. Throw that
attractive,
right
aren't
on
I?
Here, our young man.
Oh,
There you
geez.
go.
Oh.
Here you go. Couple of guys over here.
Oh. Dan, I'm really attractive. I love this.
You love this, huh?
Look.
You love this. Well, let me
I
just
like
see.
it. I
A
caught
little
him.
rearranging here. Put those there. Put this one here. All right. Try juggling.
Oh, no, Dan, it's impossible. Those poor little nano guys, they don't get any breaks down there, do they?
Like I've been trying to tell you,
Oh.
it's really different at the nanoscale, which is the size of atoms and molecules, which are too small to be seen with ordinary microscopes, but everything is made of them.
Okay, it's starting to sink in, folks. This is what Dan just said. Teeny tiny things behave way differently at the teeny tiny nanoscale, which is the size of teeny tiny atoms and teeny tiny molecules. And what's a molecule?
I'm so glad you asked. Okay, a molecule is just two or more atoms bonded together in a particular way. Like when you and I were sharing electrons earlier.
Right.
For example,
Okay.
take an oxygen atom bonded together with a couple of hydrogen atoms. Well, that's a water molecule. Get a few gazillion of these together and you have yourself a drink of water. Or take a chlorine atom bonded together with a sodium atom.
Yeah.
Well, that's a salt molecule.
Yeah.
Get a few gazillion of these together and you might have a shaker full of salt. And then there's DNA. Now that's a really big molecule that carries the genetic code for making each and every one of us. It's made of millions of just 5 kinds of atoms: carbon, oxygen, hydrogen, nitrogen, and phosphorus.
Oh my!
Carbon, oxygen, hydrogen, nitrogen, and phosphorus.
Oh my! Carbon, oxygen, hydrogen, nitrogen, and phosphorus.
Oh my!
Carbon, oxygen, hydrogen, nitrogen, and phosphorus.
Oh my!
Carbon, oxygen, hydrogen, nitrogen, and
Oh
phosphorus.
boy! Okay, Joel, that's enough.
Okay. I get it now. Molecules
Yes.
consist of atoms sharing electrons.
Right.
Atoms consist of a nucleus in the center,
Neutrons and protons.
some whirling electrons, and a lot of empty space. Which is still a big mystery to me. How can anything be solid around here? Anyway, this nanoscale stuff is sticky. Gravity doesn't matter so much. These guys could be running around on the walls like geckos.
Yeah.
Anything else you want to tell me, Dan?
Well, lots, but I'll just share one more. Have you ever noticed how small things are more reactive than big things?
You mean like when a toddler has a tantrum? Mommy! That's reactive.
Different kind of reactivity.
Right.
But hey, let's try it this way. Why don't you juggle these for everybody?
Oh.
You want to be careful with all those.
Oh, geez.
All right.
I get to do this? All right. Here we go. Check it out. This is good. Here it goes. Hey! This is boring, Dan. This is clumpy and boring, Dan.
I
They
couldn't
don't
agree
like
more.
it.
Well, let's see what happens if I break this up into smaller pieces. Here you go.
Oh, gee. Now they're in little
And one more.
pieces, and they're really reactive,
They sure
Dan.
are.
I think this is going to be a lot more fun. Let's see. Whoa! Yeah! Woohoo! Now that's the reaction we were looking for.
Like I've been telling you.
Ooh.
Ooh, very nice.
Thank you.
Smaller bits of the same material are more reactive than bigger bits.
You're telling me.
Ooh, very nice, Joel.
Woo! Yeah. Wow. Hey!
And Joel,